Okay, dear friends, today is the third session of the workshop, and believe me, today's session will help you in many ways. This is the most important concept that we are going to discuss today. So, assumption testing. Whenever we collect the data from questionnaire or whenever we collect the data from secondary sources, there are many assumptions which we need to test. So, if the data is time series, then we have to check some of the assumptions. In questionnaire, we are testing some of the assumptions. So we will discuss only on assumptions today. And it could be possible that the session will go to 90 minutes or so because the topics are many. Okay, so I selected the six concept to be discussed thoroughly. Uh, so now I don't want to skip anything. So the number of slides are around 27. So without wasting time, so this is the first concept. Normality, whenever you are applying the parametric test, the normality is the first assumption to fulfill. What is the concept of normality? You can see in the diagram when the distribution of the data is bell shaped, it is called normal data. Many statisticians found that whenever you collect the data from the large sample size, the distribution is always normal. डेटा अगर आपका नॉर्मल डिस्ट्रीब्यूटेड है तो वो लार्ज डेटा कंसीडर होता है. सो डेटा और सेकंड थिंग, if your data is normal, it is assumed to be large sample and it is representative sample. Representative means it is representing the population. मतलब population का डिट्टो सेम मान लेते हैं. So normal distribution is required in most of the studies, especially when you are going to apply parametric test. But the concept is totally misunderstood by the academic researchers. So why I'm saying so? Because I myself did a lot of research on normal distribution. Basically, you know that variables are divided in four categories. So the four categories are the nominal data, nominal. So then we have ordinal, then we have interval, then we have scale. So nominal, ordinal, interval, and scale or ratio. You can assume ratio. So ये चार तरह के वेरिएबल होते हैं: नॉमिनल, ऑर्डिनल, इंटरवल एंड रेशियो. सो नॉमिनल एंड ऑर्डिनल नॉर्मलिटी चेक करते ही नहीं है. We never check normality on the nominal and ordinal variables. So remember that there is no rule of testing normality on nominal and ordinal. They never be normal. Interval and ratio, we always check the normality, but the type of normality is different. So whenever we talk about interval data, we call the near to normality. हम एग्जैक्ट नॉर्मलिटी की बात नहीं करते, हम कहते हैं कि ये नॉर्मल जैसा है. इट इज नियर टू नॉर्मल. When we talk about ratio variable, we call it exact normality. So there are two types of normality: near to normal, exact normal. Because interval scale, like suppose you are measuring in 1 to 5 scale or 1 to 7 scale, this cannot be perfectly normal. It is always near to normal. And when the data is ratio, it is exact, it can be exact normal. So therefore, there's a confusion in normality. Normality is measured by two aspects. One, if the data is interval, it is measured by skewness and kurtosis. If it is ratio variable, normality is measured by the statistical test like Kolmogorov-Smirnov test is the most popular test to check the normality whether the ratio scale is normal or not. देखिए वो प्रॉब्लम ये है कि अगर आप ये वाला टेस्ट इस पे अप्लाई कर दो देन देयर इज अ प्रॉब्लम. So if you apply Kolmogorov test on 5-point scale, then it is a problem. And I have not found any literature where it is mentioned that the interval scale normality can be tested by statistical test. ये कहीं पे नहीं लिखा है. But कई जगह ये लिखा है कि normality of the interval scale can be examined by skewness and kurtosis. So the final conclusion I'm telling you, because in questionnaire we are collecting the data with the help of 1 to 5 scale or 7 to 7 scale. So to check the normality, you have to check only skewness and kurtosis, nothing else. Don't apply Kolmogorov-Smirnov test on the 5-point scale data. It is a misconception. Okay. Now, as I mentioned in the slide, so univariate normality means normality of a single variable is measured by skewness and kurtosis. There are three levels of skewness and kurtosis: 0, less than 0.5, less than 1. If skewness and kurtosis is found to be 0, it is perfectly normal. लेकिन ये होगा कभी नहीं. For interval scale 0, it's never not possible. So if it is less than 0.5, it is said to be normal. And if it is less than 1, it is said to be near to normal. So simply, when skewness and kurtosis is less than 1, it is assumed to be near to normal data. And if it is more than 1, then we call it away from the normal. So the word which is used in the literature is near to the normal and away from the normal. And Kolmogorov-Smirnov test should not be applicable on interval scale. They are applicable on continuous or ratio data. So this is the way we examine the normality. In case of multivariate normality means taking all variables together. So we are analyzing the normality taking all variables together. It is measured by Mardia coefficient of kurtosis. It is only available in AMOS. In SmartPLS, we don't have any option to measure it. So this is the normality, and I found this paragraph in page number 54 in the book. So they clearly mention that a general guideline, let me underline the important lines, a general guideline for skewness is that if the number is greater than +1 or lower than -1, it is simply ignoring the sign, it is more than 1. This is an indication of substantially skewed distribution. So this is an indication of substantially skewed distribution. Similarly, for kurtosis, the general guideline is that if the number is greater than 1, the distribution is two-peaked. So it is simply whenever the skewness and kurtosis are more than 1, ignoring the sign, it is assumed that it is away from the normal. So in this way, they mention the skewness and kurtosis. The second concept which we have to learn is internal consistency reliability. Internal consistency reliability is examining the relationship between the variable. जैसे अगर मैं आपसे मैं किससे पूछता हूँ कि आर यू मैरिड, and do you have children? So these two statement must be related to each other. So we assume that if somebody is having children, so he must be married. And if so, it means the two variables are related to each other. So similarly, when we ask many variables to the respondent, we assume that the variable must have some relationship between them. So a relationship between the variable is known as internal consistency reliability. थोड़ा और समझते हैं इसको. Suppose I am measuring a construct with the help of 5 items. Because all of these items are representing the same construct. All these items are representing the same construct. ये सारे एक ही construct को measure कर रहे हैं. So there should be some relationship between the statements. All these statements must be related to each other. So this relationship, the relationship between the items is measured by Cronbach alpha. So Cronbach alpha is the measurement of internal consistency. Internal consistency का मतलब है कि आपस में relationship. Internal consistency reliability. And this relationship should be same for every respondent. The relationship should be same for every respondent. So this relationship is measured by alpha. Now alpha is measured by this formula, where n is the number of statement 1, 2, 3, 4, 5. So here n is 5. This is the average correlation between each variable. ये correlation सबके बीच का average है. So 1 plus n minus 1 into r. So you can see this Cronbach alpha is measured by two things. One is n, one is r. Alpha depends upon n and r. So if n is high, r is alpha is also high. If average r is high, alpha is also high. So simply, if you increase the sample size, alpha increases. If you increase the correlation between the variables, alpha increases. So alpha depends upon two things: the number of statements and the average correlation between the statement. For example, I'm showing you with the help of one example. Suppose in one construct, there are three statements x, y, z. X, y, z. The correlation between x and x is 1, 1, 1. By y or z में correlation तो 1 नहीं होगा. And the correlation between x and y is 0.6. Correlation between x and z is 0.7. Similarly, y and z is 0.8. इन तीनों का हमने average निकाल लिया. 0.6 plus 0.8 plus 0.7 divided by 3. So the average correlation is calculated. Average correlation कितना है? 0.7. Now, if you put the values n and r in the formula, this is the formula. So the Cronbach alpha is calculated to be 0.88. So this is the way you have to find out the correlation Cronbach alpha of each factor. So one point I forget to write, that internal consistency reliability is calculated for each construct. इंटरनल कंसिस्टेंसी लायबिलिटी सिर्फ कंस्ट्रक्ट की निकलती है. अब मुझसे कुछ लोग पूछते हैं, सर एक आइटम, हर आइटम की क्रोनबेक अल्फा चाहिए, मैं क्या कोई भी नहीं निकाल सकता? सारे आइटम की एक साथ निकालनी है, कोई लॉजिक नहीं है. सो रिमेंबर दैट Cronbach alpha is calculated only for the construct. It is not calculated for the item. It is not calculated for the total number of items. No, it is only calculated for the construct, each construct. So now the question is that how much its value should be. कितनी value होनी चाहिए इसकी? So I found this paragraph in the book, and they say that the Cronbach alpha between zero point 0.7 and zero point 0.9 can be regarded as satisfactory. So between zero point 0.7 and 0.9, it is considered to be very good. But values above 0.9, बहुत साफ साफ लिखा हुआ है यहाँ पे देखिए, values above 0.9 and definitely more than 0.95 are not desirable because they indicate that all the indicators variables are measuring the same phenomena and therefore unlikely to be a valid measure for the construct. And this concept is called redundancy. But if the Cronbach alpha of a construct is greater than 0.9, it is not desirable. And this concept is called redundant. Why? Because it is believed that both items are exactly similar to each other. इसको हम कहते हैं डुप्लीकेसी, डुप्लीसिटी. डुप्लीसिटी मीन्स आप एक ही चीज को बार बार पूछ रहे हो तो उनके बीच में कोरिलेशन बहुत हाई होगा. सो the item should not be similar to each other, duplicate to each other. So if you include duplicate items in the construct, you will have a problem of redundancy. So this is the concept of Cronbach alpha. So I think we understood the concept of Cronbach alpha. So Cronbach alpha should be measured for each construct. Its value should lie between 0.7 to 0.9, not less than 0.7, not more than 0.9. 0.91 तक 92 तक जा सकता है, but not beyond that. And it is one of the compulsory requirement in pilot survey as well as in the main data. Both it is must to have. Now the third concept. So we are moving to the third assumption, which is the almost compulsory assumption in case of questionnaire data, primary data. So construct validity. Construct validity means construct which you are using in the questionnaire should be valid. देखिए वैलिडिटी का यहाँ पे कंसेप्ट मैं आपको समझाता हूँ. सपोज you are measuring the intelligence and you are asking that what dresses you like to wear. तो आप पूछोगे कि मेरी ड्रेस पहनने का मेरे इंटेलिजेंस से क्या लॉजिक है ना. It means I am not using the right sentence for measuring what I intend to measure. I am measuring the intelligence and I am asking that what kind of dress you are wearing. So the concept is that the statement which you are adding in the construct must measure the construct and how much it is relevant in measuring the construct. This is the concept of validity. So validity is one of the important concept and it is measured in different phases. So let me explain the different phases. The first phase of validity is coming with content validity. So when you are developing the scale, you are adding many statements to measure the construct, different constructs. So in this phase, you are asking the experts whether I am using the right statement to measure my construct or not. So if they are saying that you are using the right statement or this statement is not relevant, this is relevant. So validation by the expert is known as content validity. The second phase after content validity is phase validity. So phase validity means pilot survey. Now you are asking the construct to the respondent and found that the items in a construct are highly correlated measured by Cronbach alpha. So it means the phase validity is also true. Normally phase validity is measured by Cronbach alpha. So to ensure that all these statements within the construct are highly correlated, if yes, then you can say that the according to the respondent, the construct is a valid construct. We can go ahead because we are conducting pilot survey on a small set of data sets. So you cannot apply many of the tests because of the small sample size. So, but reliability is the must to check whether the phase validity is there or not. In next phase, when you collect the complete data, you have to check the validity. Now we are testing the construct validity. So we are testing that whether the construct are valid according to two component, convergent component and discriminant component. अब ये दो component हम check करेंगे. So as a layman, I'm explaining to you that what is the difference between convergent and discriminant. Suppose we are measuring three constructs. Let's say X, Y, and Z. X is measured by X1, X2, X3. Y is measured by Y1, Y2, Y3, and Z is measured by some other statements. So the convergent validity means what is the correlation between the construct and its item. So how much the construct is correlated to its items is measured by convergent validity. And if the correlation between the item of one construct is estimated with the items of other construct, मतलब मैं अगर x के item को y के item से correlation निकालूं, so this correlation must be less because we believe that x construct is unique, y is also unique, they must be different. Because they must be different, so they must have low correlation. So the correlation between items of two constructs should be less. This concept is called discriminant validity. Now, convergent validity is measured by construct loading, composite reliability, average variance extracted. So there are three measures of convergent validity. And for discriminant validity, we can use Fornell-Larker criteria, HTMT ratio, and cross loading. So ये तीन चीजें हम चेक करते हैं discriminant validity में. So we have two types of validity, and now we are going to discuss in detail. Now this is an example. In CBSAM, the diagram for validity is different. In PLSM, diagram is same, but you have to run as a measurement model. So I am taking this example. This diagram is known as CFA diagram. मतलब validity diagram के लिए हम उसको use करते हैं. This diagram is known as CFA diagram. Now there are 5 constructs in this diagram. So we are expecting that each construct must be highly correlated to its item. This is convergent validity. And this correlation, you can see the green curved arrows, these green curved arrows are measuring the correlation between the construct. And indirectly, this green line is measuring the overall correlation between item of one construct to the item of other construct. मतलब एक तरह से ये जो आपको ग्रीन लाइन दिख रही है, ये क्या कर रही है कि एक कंस्ट्रक्ट के आइटम का दूसरे कंस्ट्रक्ट के आइटम से कोरिलेशन दिखा रही है. So this correlation must be less than 0.7 anyhow. मतलब this correlation must be less than 0.7. 0.7 is the maximum limit which two construct can have. Okay. So it must be less than 0.7 in any case. So now, so what is the definition? Construct validity is measured by convergent and discriminant. So construct value, what is construct validity? The degree to which the measurement scale measure the theoretical construct that it was intended to measure. मतलब जिस पर्पस के लिए आप कंस्ट्रक्ट यूज कर रहे हो वो पर्पस पूरा हो रहा है या नहीं हो रहा है. So it is examined by confirmatory factor analysis. This is called confirmatory factor analysis, which is measuring the validity of a construct. So what is convergent validity? The extent to which the construct have correlation with its item. What is discriminant validity? Discriminant validity means how much the item of one construct are having low correlation with item of other constructs. So these are the measures of convergent and discriminant validity. Construct loading must be greater than 0.7. ये तीनों जो है convergent validity के लिए है. So I write them in front of convergent validity. So for convergent validity, construct loading must be greater than 0.7. Composite liability must be greater than 0.7. AVE must be greater than 0.5. Fornell-Larker criteria, HTMT ratio, these are the measures for discriminant validity. So let me show you that what it is. So in convergent validity, now I'm going to tell you a very key formula. Suppose this C is a construct. This construct is measured by three items S1, S2, S3. These are statement 1, statement 2, statement 3. The correlation between statement and the construct is called construct loading. Lambda is construct loading. So we have three construct loading here. Lambda 1, lambda 2, lambda 3. These are the three construct loadings. So we calculate composite reliability CR. If you see the formula for CR and AV, अगर दोनों के formula आप देखोगे, so both the formulas are using only lambda to calculate the value of CR and AV. दोनों के दोनों सिर्फ lambda से calculate हो गए. So CR depends upon the lambda. AVE also depends upon the lambda. The only thing is that it is sum of the square of the lambda and it is the sum of the square of the sum of lambda. So there are two different things. Square of the sum of lambda, sum of the square of lambda. So this is the basic difference between CR and AVE. So CR must be greater than 0.7. AVE must be greater than 0.5. So this is the condition to be fulfilled by the construct. So I am showing you the table which we usually report in the research paper. So whenever you are writing the research paper or you are writing a thesis, so this table you have to develop. So let's say the customer perspective is one of the construct. It is measured by 6 items. So this is called item code CP1, CP2, CP3. So we are having 6 items measuring customer perspective, and these are known as outer loading or construct loadings. You can see that all the values are more than 0.7. Remember one thing, most 90%, more than 99% of the values must be more than 0.6. uh, maximum these values should be more than 0.7, एक आधा 0.6 में चलेगा, but less than, like for example this is 0.589, this is not workable, this item you need to remove. So because I have seen many reviewer comments, they don't allow any item which is less than 0.6, 0.6. Like for example in this case, this 0.589, uh, if you send this table to the reviewer will ask you to remove this item because this value is less than 0.6, right? If you see this item, reviewer have no problem with this because 0.69 is close to zero point 0.7, so they will not comment on this. But they have to ask, they ask you to remove this and you can take it with this. So even 0.637 is workable, no problem. एक आध चलेगा, but less than 0.6 you should avoid. So Cronbeck alpha, you can see that it is 0.906, 894, 896, 908. So it is between 0.7 and 0.9. Up to 0.91 is no problem, but more than 0.93 is not acceptable. Composite liability is similar to Cronbeck alpha. AVE must be greater than 0.5. So we are having the condition, no problem at all. So this is the short table which you can form. Then we are having HTMD ratio. This is the measurement of discriminant validity. And all the numbers you can see in the table, all these numbers must be less than 0.85. 0.85 is written in the books, but my experience is that it should be less than 0.8. All these values must be less than 0.8. So if all the values are less than 0.8, it means you don't have any problem of discriminant validity. So second table which we have to check in discriminant validity is Fornell-Larker criteria. In Fornell-Larker criteria, the main diagonal. So the main diagonal which I am circling, they are the square root of AVE. ये जितने भी मैंने आपको सर्किल किए हैं, ये actually AVE के square root है. So these are the square root of the AVE, and all these values must be greater than correlation. Like for example, this value should be the highest value in this column. 0.755 must be the highest value in this column. 0.725 must be highest value in this column. तो सीधी सी बात है, हर कॉलम में पहली वैल्यू हाईएस्ट होनी चाहिए, सिंपल. So Fornell-Larker criteria say that the square root of the AVE, which is the first value in every column, must be greater than all other values in the column. So this criteria of discriminant validity is known as Fornell-Larker criteria. So they have a logic that attitude must be explained more by its item, not by any other item. So this is the way we examine the discriminant validity. So I already explained what is that. So discriminant validity is also known as divergent validity. It is the opposite of convergent validity. It means that indicator of one construct uh, hang together or converge, but also diverge from other construct. So it says that if two construct A and B are different, then measures of A and B should not be associated. So this is the discriminant validity. And so the first value is square root of the AV. This is the correlation. First value must be greater than all other values. एक चीज और है, discriminant validity and convergent validity are not applicable for formative construct. So I'm writing here, the construct validity is not applicable for the formative construct. Construct validity is not um, applicable to a formative construct, so no problem. We will write somewhere. Like for example, in this case, if you see that it is formative measurement, so construct validity is not applicable. Okay, I am not able to write here. No problem. Now, HTMT I already discussed. So these are the conditions that construct loading again greater than 0.7, composite liability 0.7 to 0.9, AV less than 0.5, discrete validity. So we have discussed both. So after understanding the concept of convergent and discrete validity, now the fourth assumption is item multicollinearity. Item multicollinearity means when you are measuring the construct with its item, the item should not have very high correlation with itself. Items should not be very high correlation. मतलब हम कह रहे हैं कि correlation तो होगा, बहुत ज्यादा नहीं हो सकता. So if I say, if this construct is measured by 5 or 6 items, so it is obvious that these items are correlated, but they should not be very high correlated. So very high correlation is called multicollinearity. So multicollinearity is actually is a measure of redundancy. If all the items are exactly similar, then they are highly correlated. So it is measured by VIF, variance inflation factor. This variance inflation factor of every item, ये item का निकलेगा. So for every item, VIF value for every item must be less than 3. So this is the condition. In books, it is also mentioned that up to 5 is okay. So it is up to 5, it's okay. Less than 3 is good, excellent. Less than 5 is okay, but greater than 5 is dangerous. So greater than 5 is dangerous. So you have to check this. VIF value is measuring the item multicollinearity, should be less than 3, up to 5 fine, more than 5 dangerous. Okay, now we are moving to the assumption number 4. Item multicollinearity you may not found much in the research papers. So it is expected by the reviewers. If they want, they can ask you to calculate. Otherwise, you can. It is not compulsory item. But common method bias is compulsory. So now I'm explaining the concept of common method bias. So common method bias, matlab, if your data is biased because of your questionnaire, the way you are asking the questions, if biasness is there in the responses, it means your all conclusions are biased. So we can say, अगर आपके पास biased responses होंगे, तो conclusion भी biased निकलता है. Because all of you are teaching somewhere. So suppose you are very strict to the class, and your class give you lower feedback, right? So whatever good teaching you did, you are assumed to be a bad teacher. Why? Because a student gave you bad feedback. ये हमने अपनी जिंदगी में कितनी बार देखा है कि स्टूडेंट किसी भी टीचर को बेकार फीडबैक देके बर्बाद कर सकता है. सो इफ फीडबैक इज गुड, यू आर कंसिडर्ड एज अ बैड टीचर. अपोजिट टू दैट, बिल्कुल बकवास टीचर, because they are getting the good feedback, so they are assumed to be good teacher. It is also there. So It means if the responses are biased, conclusion are also biased. So now you can understand the biased responses are very dangerous. So they can prove anything with the responses. So it is a almost compulsory requirement that you have to measure the biasness in the data. Now there are many ways to calculate the biasness. The first method is Harman single factor method. So first method I am going to explain is Harman single factor method. Harman single factor method is calculated by SPSS software. It is not calculated by the PLS. It is calculated only by SPSS. So I will show you that how to calculate the Harman single factor method. Harman single factor method gives you this table. ये जो आपको table दिख रही है, it is the result of Harman single factor method. This value, which is the percentage of variance explained by single component, must be less than 50%. ये जो value है, इसकी value 50% से कम होनी चाहिए. So Harman single factor say that if we give the condition of one single factor, the proportion of variance must be less than 50%. So this is called Harman single factor method. The second method, which is very, very popular nowadays, it is called marker variable approach. So recently, I came across with this method. Now, what is the marker variable approach? And this variable approach is very strong approach. So let me explain that what is the marker variable approach. Suppose you are measuring 5 construct in your study, A, B, C, D, E. These are the compulsory construct in your study. A, B, C, D, E, and they are measured by their items. Now we are adding one totally different construct, let's say lambda, and I'm representing it by lambda because A, B, C, D, E are having similarity, and lambda is something very, very different. मतलब आप ऐसे समझ लो कि ये दिल्ली, कलकत्ता, मुंबई, बेंगलोर, चेन्नई और ये है आपका सीधा लंदन, right? So it is this variable is entirely different from the existing variable. So these variable are there in your proposed model. ये वेरिएबल आपके मॉडल का पार्ट है, ये बिल्कुल डिफरेंट है, इट इज टोटली डिफरेंट. यू आर ऑल्सो मेजरिंग दिस वेरिएबल फ्रॉम द क्वेश्चनर. नाउ आफ्टर calculating the after collecting the data, whenever you run the CFA and you find out how much this London is correlated with all these cities, or simply how much this marker variable is correlated with this. So what is expected? होना क्या चाहिए कि इसका correlation इन पांचों से होना चाहिए नहीं होना चाहिए? Because this construct is entirely different, so this construct must have the lowest correlation between this. But if this variable, this construct is found to highly correlated with these constructs, it means your data is biased, right? मैं आपको एग्जांपल देता हूं, जैसे टीचर इज हैविंग गुड नॉलेज. आप टीचर की नॉलेज चेक कर रहे हो. टीचर इज हैविंग गुड कम्युनिकेशन स्किल. टीचर इज answering your queries. Teachering provided you notes. Teacher always comes on time and teacher is evaluating yourself, right? और यहाँ मैं पूछ रहा हूँ teacher is dancing very good. So the I am just asking a stupid variable, and The respondent is saying 5, 5, 5, 5, 5, 5. तो मतलब क्या है कि ये उसने नहीं पढ़ा. It means the respondent gave you false response. So this is the concept of marker variable. So this approach is slowly and slowly is going to be very, very popular, and you are adding one irrelevant construct in the study to check whether its correlation with other variables is lower or higher. So this concept is called marker variable approach. So I'm just reading this. We are including a marker variable that is totally unrelated to the construct of interest, and it is helping to measure the common method bias. If the marker variable shows significant relationship with other variable, it indicates the presence of common method bias. So this is the way we can also measure common method bias. Now, one more biasness is also discussed in the literature, that is called non-response bias. So non-response bias का मतलब है कि when you ask any respondent to fill the data in your questionnaire, and suppose he refuses to fill the questionnaire, आप किसी से कहते हैं कि भाई मेरा क्वेश्चनर भर दो, वो नहीं भरता. So the respondent totally denies to fill your questionnaire. Now the question is, there are many respondents like this. It is not only one or two. There are many respondents who may not be interested in filling your questionnaire. Suppose they filled the questionnaire, whether their response have any impact on the result. अगर वो लोग आपका क्वेश्चनर भर देते तो आपका रिजल्ट कुछ डिफरेंट होता. अगर हाँ, तो इट मींस योर responses are also suffering from non-response bias. So therefore, in some papers I have found they talk about non-response bias, or in many PhD presentations, the panel member asks you that how can you deal with non-response bias in the study, or have you considered non-response bias in the study? इस टाइप के क्वेश्चन आपको पूछे जा सकते हैं. Now what is the answer of that? So you say that, so I identified my respondents. I request them to respond, and some respondent fill my questionnaire without any problem. I categorize them early respondent, and I request other respondent who earlier denied to fill my questionnaire, but I pursuing them again and again, again and again. And later on, some of them will also agree to fill my questionnaire. So I call them late respondent. So my responses are now divided into two type of respondents: early respondent, and so these are my early respondent जिन्होंने बिना प्रॉब्लम के पढ़ दिया, एंड सेकंड आर लेट रिस्पोंडेंट जिनको मैंने परस्यू किया तो भरा. नाउ so I, because my respondents are early respondent, late respondent, so I am applying e-test to check whether there is any difference between early respondent and late respondent. I found that there is no difference between early respondent and late respondent. So you have to write this paragraph to address the problem of non-response bias. मतलब आपने बोला कि मैंने रेस्पोंडेंट को दो कैटेगरी में डिवाइड किया, अर्ली रेस्पोंडेंट, लेट रेस्पोंडेंट, दोनों के बीच में टी टेस्ट लगाया और देखा कोई डिफरेंस नहीं है. So it means there is no difference between the responses filled by early respondent and the responses filled by late respondent. It means my data is not suffering from non-response bias. So this is the way you have to deal with the biases in the study. So this is the biasness. And now the last topic which I want to include today is validity of a formative construct. So this is also new concept that suppose you are using a formative construct. The question is that can we check the validity, construct validity of a formative construct? Answer is yes. There is also a method for that. But you cannot check the validity by old method, like by calculating the AVE, CR, Fornell Larker, HTMT. ये कुछ नहीं लगेगा इसमें. So validity of a formative construct is measured by the concept called global item concept. So the concept is called global item. Now I'm giving you very simple example of global item. So for number one, items of a formative construct must have the low correlation. You know that Cronbach alpha, composite liability, and AV are not applicable on formative construct. So in such cases, the question is how to check a validity of a formative construct. So the concept is how to check the validity of a formative construct. This is by using a global item. What is global item? It is a single item representing the construct. Like for example, digital marketing. I assume that digital marketing is uh, a formative construct. So we are using item like you are using email marketing, you are using mobile marketing, you are using social media marketing, you are using SEO marketing. So all these are the representation of digital marketing. So we also put a single item कि my company efficiently uses digital marketing. So ये पूरा एक global item हो गया. So global item is also included in the questionnaire. And then we apply this model. So we are examining the impact of this on global item. Now the condition is that this beta, the relationship between the construct and the global item, construct और global item के बीच में जो ये relationship है, इसकी value 0.7 से ऊपर होनी चाहिए. So this is the condition of formative construct validity. So we test this analysis is known as redundancy analysis using global item, statistical significance of items of formative construct, and there should not be any multicollinearity in the formative construct. These are the assumptions of a formative construct, and it is said to be valid construct if this path coefficient is greater than 0.7. So these are the topics which I intend to cover today. So let's see what we have covered. So we discussed the how to check univariate and multivariate normality, how to check internal consistency reliability, construct validity, common method bias, item multicollinearity, and validity of the formative construct. So these are the different topics we are going to cover. So now I am going to the SmartPLS. So I am taking the model. Okay, so I am taking this model uh, to check all the assumptions. So one by one. we have six construct in this model, and because you know that in PLS only same diagram can be run as CFA as well as can be run as the structural model. So if you want to check all the assumptions, go to the calculate and go to the consistent PLS SAM algorithm. And do nothing, just click OK. Okay. So after running it, now what we need to check? Let's see one by one. So click on the open report. Number one, we have to check outer loading. So पॉइंट नंबर वन ये आपको इसी सीक्वेंस में नोट करना है जो मैं आपको बता रहा हूँ. द फर्स्ट इज आउटर लोडिंग और none of the outer loading must be less than 0.6 because I have experienced that these items are asked to be dropped by the reviewer or by the panel. So these items, the items which are less than 0.6 must to be dropped. So up to more than 0.6 is fine, but less than 0.6 should need to be dropped. So this is condition number one. Condition number two, you have to check the construct reliability and validity. यहाँ पर आपको रो A, रो C, रो A नहीं देखना है. First of all, you have to check Cronbach alpha. All the Cronbach alpha must be greater than 0.7 and not more than 0.9392. Composite reliability must be greater than 0.7 and average variance expected must be more than 0.5. तो यहाँ पर हमारे पास दो जगह प्रॉब्लम है. So these two problem are not acceptable. They have to be greater than 0.5. इनकी वैल्यू 0.5 से ज्यादा होनी ही है. So you have to be these value must be greater than 0.5. Okay, so I hope it is clear. We already discussed this. So Cronbach alpha must be greater than 0.7. Composite liability C वाली, ये C वाली, A वाली नहीं, C वाली. So this must be greater than 0.7 also, and average variance expected must be greater than 0.5. So red value is telling you that condition is not fulfilled. After that, go to discriminant validity. Number one, HTMT ratio. The all values in the table in HTMT matrix must be less than 0.8. So you can see all these values are less than 0.8. Then we have to check the Fornell lurker. In Fornell lurker, the first value must be the highest value among all. So 0.791 is more than all other values in the column. 0.694 बाकी value से बड़ी है. 0.799 is more than all other values in the column. 0.686 is more than all other values in the column. So I think all the conditions is fulfilled by the data. So we can see the Fornell lurker criteria is also fulfilled. Now after that, you can go to the collinearity statistics. Collinearity statistics may all these values must be less than 3. So we can see that all the values are less than 3. मैं इसको descending and ascending order में arrange कर लेता हूँ. So even if I arrange in descending order, the highest value is 2.5 and lowest value is 1.4. So all these values are less than 3. So my data is not suffering from multi-collinearity problem. Now the model fit. Because many reverse ask for model fit. So model fit में आपको दो वैल्यू देखनी है. This is you have to check for estimated model number one. Don't check saturated model. See only estimated model. Number one, for estimated model, SRMR value should be less than 0.08. So this value should be less than 0.08 and NFI value should be more than 0.8. If these two conditions are fulfilled, so let me write here. So if SRMR is less than, sorry, less than 0.08 and NFI must be greater than 0.8. So if these two conditions fulfilled, then you can assume that my measurement model is perfectly fine. There is no problem at all. So we have checked the most of the things in this, and now some more concept. Go to the edit, back. Now, if you click on the data, so you can see the skewness and kurtosis values. You can check skewness, kurtosis. So if you see all the values, some of the values are, I think most of the values are less than 1, but this value is more than 1. This value is more than 1. This value is more than 1. So ideally, your 90% values are more than less than 1 and 10% more than 1 are perfectly fine. So this condition you can check. Now I am showing you how we can check the common method bias by Harman single factor method. So I'm opening the data set. So I hope I have to open some SPSS data. Let me find out some SPSS data set. Yeah. So this is a SPSS data set. So I am showing you the exact method of using the running the common method bias. So go to analyze, go to dimension reduction, then go to factor and take all the variables in the model. So you have to take all the items that you want to include in the model. सारे आइटम एक साथ लेने हैं, चाहे डिपेंडेंट हो इंडिपेंडेंट हो, all must be together. Then go to extraction. Then click on fixed number of factors, that is 1. So it is one of the assumption that we have to take only one item, one factor. तभी इसको हरमन single factor कहते हैं. Then go to continue and do nothing, just click OK. And you will find second table. So this is found to be 48. So ideally it should be less than 50%, but 48% is close to 50%. So it is a little dangerous. So I expect this value should be less than 0.45. हालांकि 0.5 से कम हो तो चलेगा, लेकिन 0.48 थोड़ा सा बॉर्डर लाइन केस हो जाता है. So we have to this value should be ideally less than 0.45. So in this way we can check the common method bias. So I hope this is clear. So I have shown you that how we can check all the methods of all the assumptions that we discussed. We know how to check the normality by skewness and kurtosis, Cronbach alpha, convergent validity, discrete validity, common method bias, item multicollinearity. Only one thing which remains is validity of the formative construct. ये भी मैं आपको दिखा देता हूँ. So how to check the validity of a formative construct? Let's see. So I am creating a new project. The project name, let's say हम इसको नाम दे देते हैं कुछ भी 011 create. Then click on the import data file. So going to the SmartPLS session 3 redundancy analysis. So in this case, DM1, DM2, DM3, DM7, this is a items of a formative construct, and global item is a single item measuring the construct. Now I'm creating a model, PLSM model. So you just take this construct and define it as a formative. So I'm right click, invert measurement model. So you can see that now it is formative construct. Then you can take global item, connect the global item, and after connecting, just click bootstrap. We have to check the path coefficient of this. So in the structural model, you know that it is a structural model. I click on the path coefficient. So if my path coefficient, you can see its value. If this path coefficient is more than 0.7 and significant, it means my formative construct is a valid formative construct. So this construct is a valid formative construct. And other thing we have to check is the VIF. So we have to check the VIF, and all the items you can see are less than 3. So we don't have any multicollinearity problem in this. So in this way, we can prove that my formative construct is a valid formative construct. So I think I covered each and everything mentioned in the lecture. The only thing is that marker variable concept, I don't have the data set. Otherwise, I also show that how to check the marker variable. But I hope the concept is clear. So now I am closing this session. So give me a minute, then we will move to the discussion part. And I believe that today's session gives you a lot of insight and a lot of help